In this tutorial, we will look at a question as to what happens when we apply some force on solid foods. How do they deform? How do they fracture? Or how do they break into smaller pieces? We know that when we eat foods, we chew foods, in other words, breaking down the solid foods into smaller pieces. And also, foods break down further in the stomach. If we first look at these small video clips, we have a piece of solid material. This is aluminum. And if I try to poke it with another piece of metal, we don't notice any type of deformation. On the other hand, if I had a sponge and if I try to poke it with, again, a metal piece, I will notice that the sponge deforms. If you take a Japanese noodle called udon, and if I try to bend it, we know that it breaks, and we generally call it a brittle material. So there are various ways that a material responds when a certain force is acting on it. So we will consider a solid food in the form of a rectangular prism. So a three-dimensional representation here as shown. So the height of this solid is L, and the area on the top and bottom faces is A, and we apply force from both sides. The solid material deforms, and the new dimension then, where the height is reduced, is L minus delta L. So in this case, we are applying force only along one axis, so we call this uniaxial compression. And the height decreases to L minus delta L. Delta L is the deformation that took place when we applied force to this solid prism. We can also apply force in a tangential manner. In this case, the bottom face of the prism is attached, so it doesn't move. So because of the application of this shear force on the top, the side face gets deflected by angle theta, and the deformation then is delta L. We can also take a solid prism and apply force from all sides of that prism, and if we do that, the entire solid decreases in size, and we call this bulk compression. Another situation is where we take a solid material, let's say in a cylindrical shape, and if we apply force on both top and bottom faces, in other words, we are pulling it apart, so we are subjecting this material to tension, then the length L increases by the amount that it deforms. So the length will increase to L plus delta L. So in this tutorial, we have looked at force and deformation. Now in the following tutorials, we will look at other terms that are important as we describe the behavior of a solid material when subjected to a force.